Hello, I am Mudita, and welcome back to Satisfactory. This is my 1.0 playthrough where I attempt to load balance all of my factories, because for some reason, this is fun to me. In the last video, I automated the remaining oil products I needed. Now that I have plastic being made and brought back to the main factory, I can make the electronics. These parts are all important, and I'll be using a decent amount of them. However, I don't need to make them in huge amounts. I'll be making 60 Quickwire per minute and only 4 per minute for the other parts. Alright, so I know what we're doing today looks really intimidating because we're making 6 different parts. But if I break down each part individually, it makes it pretty manageable. There should be a pinned comment with the link to this if you want to follow along or take a look at it after. And we're back in our familiar hallway. So we've got most of the production happening down there. And I've been trying for so long to find something to fit in this room. And we're finally going to fill it up today. So this is where we're going to do all of the electronics. Even though it looked pretty crazy in the flowchart, there isn't too many machines. I actually only need 3 different blueprints for this. I'll be using my 8 constructor blueprint to take care of the Quickwire. And I'll use this 2 assembler blueprint for all of my circuit boards, AI limiters, and computers. I'll need 1 set of the 2 manufacturers for the high-speed connectors. And then I'll use 2 sets of these for the crystal oscillators. Alright, let's get all these machines placed, and then we'll just go from there. So we can go ahead and place our 8 constructors. I'm going to go ahead and give myself 2 foundations here to work with. Mainly because I'm actually going to have enough space. Next, I'm going to go ahead and place 2 assemblers, and we're going to basically do the opposite. So I'm going to give myself 2 foundations here in the back, 1 on the side, and we can go ahead and place this. All right, and then from here, I'm actually just going to zoop this out just so it's on the exact same level. And then we'll just delete the temporary ones. And now I'm going to place a second one on top. My 4 blueprint is a little bit different, so it's just a little bit easier just creating my own here. And I think I'm going to go ahead and get these centered on the foundation because I like the way that looks better, and I'm not that pressed for space. Alright, so we'll do circuit boards down here, AI limiters up here. And the reason I wanted these stacked on top of each other is they're going to have the exact same inputs, just in different amounts. The default recipe uses copper sheets and Quickwire. I'm going to go ahead and use the plastic AI limiter alternate recipe, so I'm using Quickwire and some plastic. I need 10 in total, so each one is just going to make 5. Now the default recipe for circuit boards is the copper sheets and plastic, but instead I'm going to use the Caterium circuit board alternate recipe so that I'm using plastic and Quickwire just like the AI limiters. I'm going to be making 14 in total, so each machine will make 7. Alright, so now we've got everything else. Now the machines are a little bit bigger, so let's go ahead and start with this corner. And over here I'm going to do the same thing, give myself 1 foundation and then 2 in the back. Perfect. And let's see. And same thing, might as well get it lined up right in the middle of the foundation. So we'll place those 2 there. And then what we're going to do is spin it around and mirror it on the side. Alright, 2 foundations. And right where we need it. Perfect. So these 4 are going to do our crystal oscillators. Alright, now that we've got kind of the edges set, now let's set the middle ones. And now I can make it so they're a little bit more even. Placement doesn't matter too much. Let's go ahead and put these here. And last but not least, 2 more manufacturers. So we should be able to get these perfect, nice and even. It'll give us a 1 foundation kind of gap to work with there. Alright. And there's all the machines. So let's go ahead and get the rest of these recipes set. Like I mentioned, these are doing high-speed connectors. So normally this would take Quickwire cable and circuit boards. Instead, I'd like to cut out copper from this room, so we're going to go with the alternate. This one's going to use Quickwire, silica, and circuit boards. In total, I want to make 4, so each one will just make 2. As far as the crystal oscillators go, you can probably guess, I'm using the alternate. And with these, in total, I'm making 6 across 4 manufacturers, so 1.5 for each one. And as far as the last 2 assemblers go, these are for the computers. So normally you would make these in manufacturers. The crystal computer recipe is one of my favorites, just because instead of manufacturers, you get to use assemblers, and I can just plan to make a little bit more of these in this room, and all of a sudden I've got a good amount of computers. And like the other parts, I'm going to be making 4 in total, so each one will be underclocked for 2. Alright, and with all of the manufacturers, these recipes only have 3 inputs, so we can just go ahead and delete these very top ones. I almost forgot about the first machines. So for Quickwire, we're definitely underclocking these. I actually only needed 6.5 constructors, but doing a 7-way split, it's not my favorite thing. I'd rather just underclock them more and use 8. So I need 390 across 8 machines, 48 3/4. Alright. Now that I've got all of the machines placed, recipe set, well, it's just the belt work and then turning it on, right? Wait, why are those? Alright, well, I clearly messed up these. I had to replace those 2 manufacturers, didn't realize they weren't even with the rest of them. Now we're all set and even. Alright, well, now it's belt work time. There's essentially 2 parts to the belt work. There's all of it that's going to happen within this room, and then there's the belt buses that are going to bring it to the room, and then also the belts taking it back. So I guess there's 3. But the third part's the easy part, so I just don't even worry about that. So with this project, I think I want to work on bringing all of the resources to this area, so that way all of those different belts can be kind of like the bottom ones. And then when I have to take like circuit boards to a different process, those can go up above it. And it'd just be easier if I get those initial belts out of the way. And so this is where it's going to be time to do a little bit of load balancing. Here we are underneath the factory where the belt bus from the train station is coming in. So I went ahead and did a very similar thing I did with a number of the other ones, where I just brought these very bottom ones down and under so we can just leave this space open. And then they come back up and go back into storage. Alright, so let me go through the load balancing for the plastic. Here is the issue. I have 140 on this line. I need 55. That is not a fun number to work with. 11/28's not something I really want to do. So this is what I'm going to do instead. I'm going to go ahead and use a smart splitter here. So when I'm ready to turn this on, I'll just delete this section and plug it in this way. I'm going to go ahead and add a merger right here, because the first thing that we're going to do is the priority is actually going to be to the right. Overflow will be straight ahead. And I want to remove 60. So as we can see, this belt definitely has some pretty decent sized gaps, and those may or may not transfer over. So I'm going to go ahead and just use a faster belt, and then it'll get limited down to Mark 1, which will effectively remove 60 from this, and now I have 80 to work with. 55/80, not great, but a lot better. So this will be a Mark 2. And now I just need to do 11/16. And I decided to plan a little bit ahead and made a couple of these blueprints ahead of time. So go ahead and slap this down right here. This is going to be a Mark II belt. 11/16 is really easy, because we've just got 1, 2, 3, 4 splitters, 2 mergers, because we're just going to keep splitting it in half all the way down. So here's a half, or 8/16, and that just goes all the way to the end to that merger. And then with the rest of these, we're just going to keep split it in half. So half of it went in here. So here is 4/16 into that one. And the other 4 go on. There would be 2. So that's 10 total here. And then the last 2 go into this one. 1 here, 1 here. So there's the 11. There's the 5. And if you're wondering why I didn't do 11/12 out of the first 60 that I siphoned off, that is an excellent question. And I honestly don't have a good answer for you. So let's move on. Let's take a look at the quartz and the silica. So let me show you what we're working with here. For the quartz, I need 60 even, which is pretty nice, out of a total of 210. Which that looks awful. But that's actually only 2/7. So I could use a smart splitter. 2/7 isn't too bad. And I already have a 2/7 and 5/7 split from earlier on in the save. So I'm just going to use that, and we're going to plug it in somewhere over here. But just so we don't have to look at the horrible clipping, I'll worry about that later. For the silica, I need 50, and that belt is 450. 0.1111 is 1/9. So that one's going to be real easy, and I'll just kind of give you a quick example. It will be obviously over there, but just to not clip into things, we'll just put this right here. So it'll be basically just 2 splitters with 2 mergers. The 450 is going to plug in right here. And then if I split that in thirds, that would be 150, 150, 150. So we'll take that 300 and send it on into that merger. And then with this 150 amount, we'll just split it all 3 times. There's 50 and 50, leaving us with the 50 we want. And the 400 is left on top. The last input I need is Caterium. I need 78. So you know this is about to get interesting. This belt has 240. And this right here, oh, it's so deceiving. I would think that, oh, this must be a really simple one to work out. But if we simplify it, that's 13/40. Not the best, not the worst. So behold, my way to split it 13/40 and 27/40. Only ever so slightly ridiculous. So this is going to go probably somewhere over here. And let's just go ahead and place it. I'm going to rearrange this and clean it up, but let's take a look. So I know this looks super crazy, but it surprisingly wasn't as horrible as I thought it was going to be. So the initial amount gets plugged in right here. And then we're immediately breaking it in half. So we've got half up here going into this merger. The other half goes into the next splitter. And then again, we're going to split that in half. So half of it is going to go up to this very top merger. And then the other half goes into a splitter. And then that half is getting split in half again. So now we're down to an 1/8, right? So that was a half, that was a quarter. This is an 1/8. So now with this, we're going to do a 5-way split. A 1/5 and an 1/8, that would give us 1/40. So we've got the part that loops back. This one right here is the 3/5 that goes up to the right merger. The other 2 go to the other one. And that's it. Honestly, wasn't as bad as I thought it was going to be when I was making it. Let me clean all this stuff up, and then we can work on the belt work within the room. The Caterium ingots are the only ones that I've brought all the way into the room. So if we come out into the hallway, see the Caterium right here. And then we've got 2 more belts that just end right there. I'll be honest, I can't quite remember which one's quartz and which one's silica at the moment, but those are those. And then if we look on the other side, there's 2 more empty belts. We got plastic and rubber. I went back to the source and then kind of traced the lines back. So this one is quartz, this one's silica. Let's figure out where to plug those in. All of the quartz is going to be used for the crystal oscillators. And it's all going to be marked 1 belt. The quartz is the one that I needed in the highest volume. This is the one that I usually put on the bottom. So let's go ahead and just bring this down right through the middle here. And let's just go ahead and put a floor hole. We've got enough room on the other side. Perfect. All right, so that's where the quartz is going to come in. The silica is all going to be used in the high-speed connectors. And that would be the second height. So let's go ahead and bring it this way. Have it come right down the middle of this foundation. So to create a short lift on these, I just like to come right here to the center of the foundation. And then it's got to have plenty of space. And then we just need to make sure that the direction is facing the correct way. Delete that. And that goes in just like there. And there's our silica. Now we just need to sort out the rubber and the plastic. For the rubber, it is all being used by the crystal oscillator recipe. And that's going to be the second level, so we're just going to do the same thing. Place a stackable right here. Alright, I'm going to do the same thing with the rubber. Go ahead and place that. For whatever reason, if I had the belt there, it wanted to come all the way down and snap to the belt, even though it wasn't snapping to the end. That was very strange. Alright, and then the last piece is the plastic. Definitely going to rearrange some of these inputs. I'm not quite sold on them being right on top of each other. But for now, this is going to work. Alright, so with the plastic, I've got 55 on this belt. I need 20 to go to the circuit boards and 35 to go to the AI limiters. Sticking with the theme of having the less full belt on top, that means the plastic would go on top. And for both of these, the Quickwire is going to be on the bottom. So let's go ahead and figure out this mess. Okay, so let's make sure all the belts are correct. We are just going to group this all together because sometimes when the machines have really nice outputs, you can do some of the load balancing right out of the machine. Like if this was 60 and, you know, I only needed 20 or 30 or something like that. It's much easier just to do the load balancing right out of the machine instead of grouping it all together and then splitting it up. But with a number like that, it's just going to be easier to group up all 390 and then do any load balancing. So if we've got 48, we'll just call this 50. So this would be 100 on all of these. Let's make sure we get all of this changed. All right, so that would make this roughly 200. So make sure these are Mark 3. And Mark 3. There we go. Okay, so now out of here, we can rely on 390 coming out. 390 sounds like it wouldn't be that bad of a number to work with. And it's not. It's obviously divisible by 3. But 130, not the greatest to work with. Alright, so let's go ahead and start with a smart splitter. So that's just going to make my life a lot easier here. And it's a 390, so definitely a Mark 4 going into here. I need this stuff to split off between my storage and 3 different recipes. So having to split it that many different ways, the smart splitter definitely takes a little bit of the headache out. So the first thing we're going to do is we're going to send the any to the right, overflow forward. So the first thing we're doing is we're taking out the 60 that's going to go to storage. So let's go ahead and just add a wall hole there. I already know I can't go all the way to the very top. Those ones are all full. So this one is going to go right here. And it doesn't quite reach, which is okay because I actually want to do a stretch of slightly faster belt just to make sure. This is close. 390 on a 480 belt is pretty close, and chances are this wouldn't have any gaps transfer over, but having a stretch of the Mark II belt. And this will just make sure that that's a full 60 belt headed to storage. Alright, so now I'm down to 330. Let's go ahead and grab another smart splitter and put that one right in front. Little Mark IV belt. The circuit boards require 60 as well. So we're just going to do Mark 1 to there, and then a small stretch of that Mark II belt just to make sure that that's completely full. Then we'll set up the smart splitter the same way, any to the right and overflow center output. So now we'll be down to a full 270 belt. So let's go ahead and add one last smart splitter. And then for this one, we're going to do any to the left and then overflow straight ahead. With the high-speed connectors, I need 60 each machine, so 120 in total. Nice and easy. We just need a Mark II belt and plug that right into there, which should leave me with 150, which is the exact amount I need for the AI limiters. So for this last one, let's just grab a Mark III lift, turn it sideways. Yes, at the right height. There. Nailed it on the first try. All right. And that is my Quickwire load balanced. Now I can work on the plastic, because I knew I was probably going to want to bring that up and over this mess. All right, so again with the plastic, I've got 55. I need 35 up here and 20 down below. And unfortunately, I think I made this one a little while ago already. And I added the info on the right. So 4/11 is on the bottom splitter, 7/11 is on the top merger. Well, that's perfect, because the 4/11 is the one that's going to stay on the bottom anyways. I may need to move this around later, but for now, let's just plop it down here. Just to give you the brief overview, whenever you have those really odd splits, like 5, 7, the 11th, you're splitting it one more time. I'm cycling it 12 ways, and one of them is going to get cycled back to the initial merger. So the initial amount comes in to the merger, and then that goes into a splitter, and eventually you have one bit that cycles back into the merger. Alright, so to get the plastic up to the top floor, that's nice and easy. We can just put this up here. I think that should be the right height. Terrific. Go back to my normal color, there we go. And then for this one, because we need to plug it in right here, I'm going to go ahead and just use one of my stubby lifts. So just go ahead and cycle through till I find the right one. Is that it? That looks like it. Alright, so let's go ahead and place this one. Place it right here. Line it up with that. Good. Alright, so mark 1 for everything here. And there's my plastic load balance. Alright, not too bad so far. Let's start getting everything else going to where they're supposed to be. So we've got the Quickwire done. Both of these have all of their inputs. High-speed connectors. Let's see what last one we need. Circuit boards. Hey, look at that. We just finished it. So let's figure out how we're going to do this. I am making 14 circuit boards, and I need those to get split in between 3 different places. The high-speed connectors need 4. And I need 6 for the crystal computer recipe, along with sending 4 into storage. So the way I decided to split these is if I group 2 of the 4s, that's 8, then the other amount is 6. Or in other words, 3/7 and 4/7. And this is a pretty easy blueprint and very flexible. You could rearrange this in a bunch of different ways. And like I mentioned before, with these kind of numbers, you're starting with a merger and one piece is going to get cycled back. We're just splitting it 8 ways. That's why there's 3 splitters. So this is getting split in half and then quarters. And then here's our 1/8. So these are actually our 2 outputs. And I may need to slide this forward a little bit actually. Kind of forgotten where I had the exits come out. That looks good. Alright, so there's my 3 and there's my 4. Alright, so let's get these to where they need to go. We're going to go ahead and just throw down a splitter. Let's see. I guess right here. Alright, so this is the 4. No. So this is the 8 right here. This right here is going to go to storage, and I'm just going to do this because I never used that. And I definitely want to delete it. But the other half, I normally would put it in here. have it go that way, but then I'm realizing it's probably going to get in the way of that belt. So let's just use this one. And the other 4 will get plugged in to our high-speed connectors. So that's all the inputs for these done. Nice and easy. These last 6, we need to head on over to here. So there's a good chance I'm going to rearrange some of this stuff. But for now, we'll just get it done, and then I can clean things up later. Alright, so we're just going to grab ourselves a stubby lift, and let's see, find the correct one. Is that it? No. There we go. Alright, so we'll just have it run right down the edge of the foundation. No clipping. Perfect. Let's grab the 6 circuit boards, plug it into there. And from here, let's head on over. And there's the circuit boards. Those should be the ones on top, right? No, the circuit boards are the busier one. Oh. Okay. Well, we were still going to need to get up and over that. So now we can just do it like this. Alright, so there's the circuit boards done. Move on to the next one. Oh, that's right, the plastic. Probably get rid of that. Too far. We'll go back to here. Stubby lift time. So we'll go ahead and place one here. And we'll do the opposite. Right over here. Move that into there. Snake this across. And that's the plastic dealt with. Alright, let's see what's left. There's an opening. Let's deal with the crystal oscillators. Quartz crystal done, rubber done, and limiters. So I need a total of 6. And I'm making 10 in total. Alright, so for the circuit boards, oh, guess I forgot to plug that up. Alright, so that's where those go. Now for the rest of this split, we're gonna make this busy. Alright, so we're just gonna throw down some temporary foundations here. I already have 2 different blueprints to get me what I need. The difference is, if you look at the little info spot, either the 2/5 is on the top merger, or if it's on the bottom merger. Because we're building this on top of a 4-meter foundation, it's already the height of that right there. So I want the 6 AI limiters to end up on the bottom. That would be the 3/5 on the bottom belt. So let's go ahead and use this one. Make sure that there's no clipping. Right. And then I can just grab a lift and let's see, it'd be 1, 2, 3, 4. Each little notch is 1 meter. Alright, and we can delete the machine. There we go. Alright, so that is how we are gonna split off the 6. Now we've got this, which is on the bottom belt, and now I think I'm gonna run into another problem though. If I go up to this height, oh, that clips right through here. Well, I guess it's time to move some stuff around. But before I get to that, let me show you the last piece. So that right there is going to that piece. And then the other one, this has the 4, that's going to storage. So now the last input that hasn't been done, I forgot the circuit boards. So now I just need 2 crystal oscillators to plug into this right here. And since each machine is outputting 1.5, I've got 3 on this merger. So that makes this really easy to do. So we can just grab another merger, place it over here. Now I've got my 2/3. And this is the one that's going to storage to group up with those 3. So I have 4 in total. And then I just need to get this up and over and send it on into there. Obviously without the weird height difference. Now what I'm going to do is go ahead and clean up this mess and connect those final connections. And work on belting the outputs. So give me a second and I'll show you what I've done. And voila. We have cables and beams and lights. And we are almost good to go. Almost. So let me show you what I did. Alright, so here is the revised craziness area. I kind of like it. It did get a little bit messy, and that is alright. But there's no clipping, and everything misses each other just barely. But it just adds a little bit more busyness. Alright, let me show you what I did with the outputs, and then I'm going to tell you why I'm going to tear it all up and change it. So the computers just come out here and then up and over there. And so we've got 3 of the outputs on that wall. And then if we come to the other side, we've got the other 3 outputs right there. So this would be the Quickwire and then the circuit boards and AI limiters. Which I did think it was fun because I got to bring those belts up and over all this stuff, and it just adds to the busyness. And I got these belted all the way down into storage. So even here, I had them all as 6 different belts, and they snaked through the whole factory like that. And once I finished plugging them all up, I realized this was silly. And this right here is the perfect use for a sushi belt. And so now instead of 3 outputs over here, there's only 1. There's still 1 more. So I deleted 4 out of the 6. I decided leaving the Quickwire on its own belt because it's a completely full Mark 1 belt. I just like the way that looks. So that one's staying the same. But with all of the other parts only having 4 per minute, it was just really silly putting only 4 per minute on a 60 per minute belt. Whereas I could group up 5 of them and then I would have 20 on a 60 belt, and that would look much more full. So I am bringing the circuit boards around here, and then we're just merging up the high-speed connectors. And that just comes over here. We add on 3 of the crystal oscillators, and then that's just going to come around here. And instead of the parts leaving up through here, which was where I think I had it before, I just added a merger. So we're adding the computers, since those are basically in the middle of the room. And then those come around and then join up with that very last crystal oscillator. And then from here, then it leaves right there. But that way we get a nice fun parade of it running through the room, collecting all of the items, and then heading on into storage. So let me show you that. And now it just looks like this. Much cooler. So we've just got the 1 sushi belt coming in and coming into a smart splitter. And so this very first one, we've got circuit boards going center, any undefined going to the right. And then with these, they're all oriented at a 90-degree angle from that first one. So the output is going to go to the left, undefined center. Same with all of these until we're down to the very last one, where all we should have is crystal oscillators and computers. And then the last one is the Quickwire, since it has a belt all to its own. This right here is what I would consider like the perfect use for sushi belts, is because they're going to storage. If anything backs up, I've got smart sync set up on all of these different things, and so I'll never have an issue with these lines backing up and creating any sort of headache because one fills up and now the rest can't go through. Because if any of these storage containers fills up, they'll just head on up to the sinks like all the rest of this stuff. Guess I forgot to clean up my temporary foundation here. Help belt everything over. Alright. There we go. Now the storage section is done. Alright. Before we plug all this up, one last thing let me go over. So I did go ahead and plug up all of the inputs to their load balancers and then just made sure that they had a way to continuously sync so things didn't back up. But if we take a step through here, you can see we've got the plastic, the rubber, the quartz, the plastic, the silica, and the Caterium all ready to go. We just need to connect these and it'll come to life. Alright, let's go ahead and start with Caterium since this is the only Mark II belt. And let's start that stopwatch. I spy with my little eye. First computers. Excellent. I'm going to let this run for just a little bit longer, make sure that we get all green lights across the board. And there we go. We've got our electronic sushi belt headed to storage. I love to see it. So that's circuit boards, AI limiters, high-speed connectors, crystal oscillators, and computers, all at a rate of 4 a minute headed to storage. And also 60 Quickwire. That is mission complete. That's going to do it for this one. In the next video, I'll be taking you on a world tour. I'll still be adding 1 or 2 things, but the focus will be showing off all I've done before I send off the space elevator for this phase. So look forward to that, and thanks for watching.